Hello, we continue to multiply decimals by a whole number, noticing the patterns in the placement of the decimal point. Let's consider the following examples up above. We are on page 21 of our textbooks. So let's take a look at problem number 2. Notice that we are multiplying only by whole numbers. Okay, notice that we will be multiplying our factors by whole numbers such as 5 and then 8. Let's do first 3 examples, A, B, and C. Step 1, let's first compute 542 times 5. You do your typical calculation you have done since 4th and 3rd grade. 542 times 5. Let's do it stacked. Let's do one example. So 2 times 5 is 10. We group 1. 4 times 5 is 20. We add 1. And this is 25. So we group 2, 25, and 27. So we have 2,710. 2,710. Well, my friends, take a look. In the following examples, we're going to be multiplying 54.2 and 542 thousandths. So let's look at what the product will look like in examples B and C. So we can basically copy the same digits, 2710, except we must have one decimal place in the final product. So the answer will be only 271. And let's see if it makes sense. We are multiplying 54 times 5, right? If we round this is going to be about 54 times 5. So it makes sense that our answer is a little bit more than 250. Let's consider example C. We have 542 thousandths. Notice 3 decimal places multiplied by 5. Again, we might as well copy the same digits, 2, 7, 1, and 0. We have 3 places, 3 decimal places on the left. We must have 3 decimal places on the right, and our answer is 2.71 hundredths. Now let's see if that answer makes sense. Notice we have 0.542. It's about a half, right? 0.5 is about a half times 5, and we know half of 5 is going to be 2 and a little bit more. It's about 2.5, and that's exactly the answer we get. Let's jump down to the following few examples. Let's notice number 4. We're going to learn to estimate our answer, same as in number 3, but I'm going to only do example number 4 so we can do it ourselves. Let's consider the top line. So step one, let's first estimate, and part 2, let's compute. Let's find the value. That would be our step 2. So we have a two-step solutions here. Let's first do our estimations for A, B, and C. For A, 4.82 times 3 is the same as about 5 times 3, and it should be about 15. Example B, 3.63 times 6. Let's round 3.63 to about 4 times 6, and our product should be about 24. And finally, 9 times 43.25. Let's just round it to 9 times 40, right? Just to make it quick, just to make a quick calculation. Our answer should be around 360. So let's now do step 2 and find the actual value. Find the actual value for A, B, and C. Well, I hope, my friends, that you're very good at multiplying, doing the stack multiplication as we've done before. So in any case, 482 times 3, it's like multiplying 482 times 3, and the digits would be 1416, except look at the placement of the decimal point. We have 2 decimal places in one of our factors. We must have 2 decimal places, and the answer will be 14.14. Notice how close our actual product to the estimation of 15. Let's take a look at part example B. 3.63 times 6. Well, first, it's as if step 1, multiply 3.63 times 6 using your usual stacked algorithm, and ignore the decimal point at first. Ignore it, and you will find that it's 2178, except we must place the decimal point where? We have 2 decimal places in the top factor, therefore we must have 2 decimal places in our product. And the answer is 21.78, which is very close to our estimate of 24 right above, you see? And finally, part C, 9 times 43.25. Again, let's do our computation, finding our product, 43.25 times 9. Step 1, multiply using your standard stacked algorithm. Ignore the decimal point first. Ignore it. Let's find the correct digits. And we have 389 and 25. Now, let's find where do we place the decimal point. In one of the factors, we have 2 decimal places. We have no decimal places in 9. It's a whole number, and therefore our final product will also have 2 decimal places, which results to 389.25. Notice how close our answer was to our estimate. And that is the point of estimation. The reason we estimate is to find the quick answer. What should we about have in the final product? And A, we should have about 15. If you get 150 or 1500, you know you're on the wrong track. Let's compute the below examples for D, E, and F, and we can compare answers. Let me clean up my doodles. Let me clean up. Okay. So let's see. First, let's estimate 9.348. It's about 9 times 5. We should get a product that is close to 45. In question E, we have 5 and 46 thousandths times 7. Well, it's about 5 times 7, and the product should be about 35. And finally, for F, we have 27. Well, I would round 27 very quickly to about 30. And 30 times 4 is about 120. We should have an answer around 120. Now let's compute the actual answer. Again, how do we compute the actual answer? You use the stacked algorithm, 9.348 times 5. If you go with your stacked algorithm, you will see that the digits are equals to 4647, and take a look, 74 because 8 times 5. So take a look, we have 3 decimal places on the left, which means we have 3 decimal places on the right, and our answer is 46.470 thousandths. Notice how close our actual answer to our estimate. Next example, step 1. First, compute the product, 5.046 times 7. Again, do your multiplication and ignore the decimal place. First, find the correct digits, and the correct digits would be 2, 7, 3, 3, 5. Now notice, we must place the decimal point correctly. We have 3 decimal places in one of our factors. We must have 3 decimal places in the final product. So we have, the answer is 35.372. And notice how close our answer is to the estimated product of 35. I hope you get the idea. Again, to summarize, how we multiply decimals by whole numbers, proceed with your standard algorithm, then calculate the total number of decimal places you have in your factors, and that should be the number of decimal places in your final product. When in doubt, you can always use estimation techniques to find if your answer is reasonable.